Well, I told you this is going to be a 2-video series. It might turn into a 3-video series because I always tend to talk longer than I expect. This video is the second of maybe 2 or 3 videos dealing with volume and surface area of spheres. And so I want you to know, what do we do if we have a half sphere? Okay? Here's the generic formula for the surface area of a sphere, but that's not the same, no longer, this, if we're working with a half sphere. See, what I was doing whenever I did the 4 pi r squared is I was finding the surface area of this total shape, right? The area of the external surface, which is curved. Well, if it's 4 pi r squareds for the total curved surface, then it would make sense that the surface area of a hemisphere would be half of that. So no longer do I have 4 pi r squareds, I have 2 pi r squareds. And that 2 pi r squared will give me the curved portion of that surface, right? But you know what I did? You know, when I took a knife and I cut that circle in half, when I cut that sphere in half, I created a new external surface that wasn't there before, and that is this circular base that I have, right? So I have 2 pi r squared, which is going to tell me the top portion here, but then I have to add in a pi r squared for the base. And so it turns out that the surface area for a hemisphere, I would recommend memorizing this, okay? Because I think that's going to make more sense to you given all the problems that we've done dealing with surface areas so far with non-spheres. But if you want a shortcut, it turns out just to be 3 pi r squareds. You got 2 of them for the curved surface and a single pi r squared for the base. So we have a modified formula here, one of which you need to memorize. I think this one is better, the top one, because it shows me that you know where you're getting that from. Half of the 4 pi r squared for the curve, and then a single pi r squared from the base. For the volume, it's a little bit easier. See, I had the full circle was 4/3 of pi r cubed, and if I cut the volume in half, I really don't care about external surfaces, so all I'm going to do is take this thing here and divide it in half. So instead of 4/3 of pi r cubed, my only modification is 2 pi r cubed. So the formula for the volume of a hemisphere is 2/3 of pi r cubed instead of 4/3. All right, now let's go do some stuff with this, right? One of the things that you have to do to work backward might be to work backwards, okay? So for instance, let's say that I give you the volume of a sphere, okay? No, let's do surface area of a sphere, okay? Let me pick a number here. Let's say that all I know is that the surface area of this shape happens to be 676 pi square inches. And I want to know the radius. What is r? Okay, so I'm just making up numbers here. If this is 676 pi, what is the radius? Well, here's what I know. The surface area is pi r squared. And the surface area in this case happens to be 676 pi. And I know I got that somehow by multiplying 4 pi r squared. And my job is to figure out what in the heck that r is. Well, the convenient thing about this is you'll notice that I have a pi on both sides, so that goes away. So now I'm down to 676 is equal to 4 times r squared. Well, if I take the 676 and I divide it by the 4, I get 169. So the goal is get r squared by itself. Don't square root until you have r squared by itself. Let me write that out one more time. Don't square root until you have r squared by itself. Okay? At this point in time, to get rid of the r squared, I square root both sides, and it turns out that r is equal to 13 when I do this. Right? So 13, it looks like if it was square inches, now I'm down to inches. The key is down here at the bottom. That is the big idea for this problem. We can do the same thing for hemispheres. Let's avoid the surface area, okay? Let's say that I had the volume of this hemisphere. Let me pick out a number here. Let's say that the volume of this thing was 2,250 pi cubic centimeters. Okay. Well, normally for the volume of a sphere, I would have 4/3 pi r cubed, but this is a half of a sphere, so it's 2/3 pi r cubed. And I know then that if I did 2/3 pi r cubed, I should get 2250 pi. Once again, conveniently, you have a pi on both sides, so those go away. So I have 2/3 of r cubed is equal to 2250. All right. Now, in order to get rid of the 2/3, I need to divide both sides by 2/3. But better off, we're thinking to multiply both sides by its reciprocal, which is 3/2. Let's take, because if we do this, the 3's go away over here and the 2's go away over there, right? Multiply by, we'll multiply by 3/2 to get rid of 2/3. So if I take 2250 and I multiply by 3 and then I divide by 2, I end up with this. R cubed is equal to 3375. Now the idea is this. We need to figure out what the cube root of r is. Of 3375 is. In order to get rid of r squared, we square rooted it. So on your calculator, you need to figure out how to cube root. The easiest way that I can tell you to get rid of a cube root is to raise both sides to the 1/3 power. I can do that as long as I'm fair. Okay, you may have a cube root button on your calculator. If that's the case, I recommend you use it. Okay, like for instance, on this calculator here, as cheap as it is, if you look really close, right above here, you can see a little square root sign, and it has a 3 next to it. That's the cube root button. So on my calculator, I can just do this. It's 15. 15 cubed gives me 3375. But I also know that I can raise 3375, and I can raise that to the 1/3 power, and it does the same thing. The reason that I do that is because when I raise a power to a power, I multiply exponents. The 3 times 1/3 gives me r to the first. So the radius is 15, I put centimeters, right? The r cubed is probably one you're going to need a little bit more help with the first few times. Just remember, to get rid of a cube, I raise to the 1/3 power, because 3 times 1/3 is 1. All right, that's enough for this video. I've hit 8 minutes on it as well, so I just got a couple of advanced problems to finish off the notes, and then we'll be done for the day.